Robot Talk is the podcast that sits down with robot enthusiasts from around the world and asks them the questions you always wanted answered. Like, how does the robot know where it is? And how does that thing work? Hello everyone! Welcome to Robot Talk. I'm your host, Claire Asher, and this week we'll be exploring the surprisingly complex world of warehouse stock mapping robots. From why they're needed to how they find their way around. Before we get started, please remember to like or rate this episode and leave us a review if that's something you can do on the platform you're listening on. And don't forget to share the podcast on social media or tell your friends about it. It really helps us reach more listeners, so thank you in advance. So, without further ado, I'm excited to introduce this week's guest. I recently had a great discussion with Guillaume Doisy from Dexory, all about autonomous warehouse robots, mobile robotics, and software. This week, I'm talking to Guillaume Doisy, lead systems architect at Dexory, a UK robotics and AI company building state-of-the-art, fully autonomous mobile robots for use in warehouses. Hi, Guillaume. Welcome to the podcast.
Hello.
So first of all, can you tell us a bit more about what Dexory does?
All right. So Dexory, to sum it up, is building digital twin of warehouses. And it's trying to answer a very specific problem is that it's a bit embarrassing, but in warehouses, most of the time, operators don't know very accurately what is where and what exactly they have in their warehouse. I cannot share with you numbers, but it's kind of incredible each time we go to a new warehouse to see how much inaccuracy there is compared to what's out there and compared to what is in the IT system. So all of that is creating massive inefficiency in production. So it's a huge value for operators to know what's in their warehouse. So we are currently doing that with a massive indoor mobile robot. Maybe in the future it's going to be something different. But to sum it up, again, what we're trying to solve is to show what's out there to the warehouse operators.
Okay. It's kind of amazing that these warehouses don't know what's there, but I guess they're huge warehouses.
Yeah, they are incredibly huge, and the average size of warehouse really increased in the past decade. I'm spending most of my time on the field in warehouses, and I'm still amazed how fast they grow everywhere and how big they are.
Yeah. So I was looking at some of the videos on the Dexory website, and there's a cool little robot. Well, actually, probably quite a big robot. But for the listeners, can you describe what the robots look like and how they work?
So it's kind of a small car in terms of scale. It's about 500 kilo, and it has a massive extendable tower. So in order to be able to see very high, up to currently 12 meters, but soon we're going to go even higher because warehouses today, I mean, it's hard for the general public to represent it, but a small warehouse is 12 meters high. A big warehouse can be up to 20 meters.
Wow.
So the robot needs to be able to see up to the highest point of the warehouse. So we have this car-like robot that has this tower that extends.
Okay, and that goes around and scans whatever's in the warehouse?
Exactly, scans. And our goal is to be able to scan a full warehouse overnight.
Wow, okay.
Whereas usually, when it's done manually, it requires something like 1 week, and it's usually done fully and accurately once or twice a year.
Okay. So how often would your robot be scanning the warehouse? Just once or every so often?
Every night.
Every night?
Every night.
Okay.
Yeah.
Fantastic. The way you describe the warehouses, they sound almost like forests, Yeah,
that's a good analogy. Yeah, that's a good analogy. Yeah. It's it's high. You have tight spaces, and it's very easy to get lost.
Yeah. So one of your responsibilities in the company is to build the robot's autonomous functionality. And we've talked quite a bit about the challenges of developing autonomy in previous episodes of the podcast. But can you talk about some of the challenges that are maybe a bit more specific to the warehouse environment?
Yeah, sure. Challenges in warehouse are kind of common to most mobile robotics environment, but like it's a bit different in the way that warehouse are highly structured. So it's a bit easier because of the way they are structured. The ground is flat, so we like to say that we evolve in a 2.5 dimensional world. So the robot itself would move in like in 2D, but it has to avoid obstacles that can be in 3D, like height obstacles. And we have a tower that extends, so we have to take care of like the height dimension. However, it's a very, very dynamic environment. It is constantly changing. The only thing that is not moving in a warehouse is the structure of the racks. But what's inside the racks is like moving at a very high frequency. Meaning that if you take a picture of what's in a rack, or if like basically build a digital twin, you wait a few days, and more than 90% of what you've seen before will have changed.
Wow!
And this creates a huge challenge for mobile robots, because the hardest problem in mobile robotics is localization. Basically, for the robot to know where it is. It's not a problem for outdoor robots because there is GPS everywhere for free, but indoor it's kind of hard to realize. But there's no GPS, so you have to find a strategy for your robot to know where it is and not get lost. And what we do is to build a map of the environment and then to recognize where we are relative to this map. So this is kind of relatively mature in the industry for an environment which is static, which is not evolving over time. But for an environment like a warehouse, it's incredibly hard, and I don't think there are many people that are able to solve it.
So when the robot goes into a new warehouse for the first time, does it have any like advanced information about the space, or is it just mapping it fresh from scratch?
We are mapping it fresh from scratch. I mean, we tried, and I tried with other company before in the past or during my career to get a priori information from warehouse operators. They always have some form of map lying around, but again, most of the time it's highly inaccurate. So it's like not a very complex task. It consists of like showing the robot around, basically, to drive it everywhere, and then it does a map, and then it can localize against it.
Okay. And what kind of sensors does it have on board to do that?
Well, all kinds. If we start from the bottom, we have encoders on the wheel, so we can estimate how much the wheel rotate, and with a very simple kinematic model of the robot, we can estimate how much it moves. And then we have like multiple LiDAR sensors, which are like range sensors that are like used for localization and also for detecting obstacles.
Cool. It's a seemingly simple task that is evidently not as simple as it sounds.
Yeah, it's like it always surprises people, but like navigating from a point A to a point B indoor, even if the environment is relatively clean, is still very hard to do, and hasn't been solved universally. That's the main reason why I have a job. But I mean, you will see amazing demos of proof of concept in labs, but once you're out there, once you're faced with all the noise of the real world, all the uncertainty, everything that you cannot plan for, then it's hard to work to make this robot work.
Yeah, definitely. And so you create this digital twin. What does the company do with that? They just use it to know, where stock items are and just makes their operations more efficient, I guess?
Yeah, there's like many possible use cases. We can start from the very simple one that is like basically an inventory. But once you know where things are, you can also analyze how things moved. And basically we are like generating data, and then from that data, up to your imagination. But like again, if you a very simple use case in inventory, but we can do things much more complex in terms of recommendation of where to put your pallets, or I don't know, finding if an anomaly like an rack that maybe is damaged, or I don't know. We even had like a request that we are considering of like trying to detect insects or potential rodents in pastas. But yeah, again, once the data is out there, you can analyze it. We can analyze it. Our customer can analyze it. But what we are focusing on is like getting the data.
Yeah, sure. So you're also a long-term contributor to the Robotic Operating Software, ROS, which has been mentioned by my guests many, many times, but has never been the focus of the conversation before. So for listeners who aren't familiar, what is ROS, and why has it been so transformational for the robotics industry?
So ROS is many things. I mean, it's, as you said, it stands for Robot OS, though it's not really an operating system. It's more like a middleware or a framework. But like to start with, it's like it gives you an architecture, a framework to build robotic code. Where the principle is that you dispatch your code in multiple nodes that are communicating through a publication subscription modality, and that enables you to have like a very resilient software architecture. Because if one of the node of your stack is failing, you're still alive, basically. The stack, the whole stack is not dying. But it tried to standardize abstraction interface. The idea that every roboticist doesn't have to reinvent the wheel every time they need to develop something. And by abstraction interface, as an example, let's say you have a LiDAR sensor. If the data that you get from the LiDAR is formatted in a specific way and in a standardized way, then you can change the vendor, your supplier of the LiDAR, without having to change the higher level code that will process this LiDAR data. Same principle for motors. If you have an abstraction to control your motors, you can change the motors, you can change the motors controller, but you won't have to change your navigation algorithm.
Right. Okay.
So there's this idea of like standardizing abstraction interface towards hardware, but it's also for researchers, for instance, it gives them a way to show that their algorithm works, because they can release their work as a package that will be kind of working plug and play with the rest of the software stack of other people, and then you can try a new algorithm very easily. But for us, I think at the core of it, there's also the idea of open source software.
Yeah.
So you have many people from many different fields and from the private sector, from the research world, collaborating. And for me, for the mobile robotics industry, it's very, very important. And I think even if it's not publicly displayed, probably more than 95% of the mobile robots company out there are using some form of ROS code.
Wow.
And to me, the most important part of ROS, kind of project of ROS, is the navigation to stack.
Okay.
So the navigation to stack that we use a lot in Dexory was created and is maintained by Steve Masensky, who was funded and was working directly for Samsung for many years.
Okay.
But at the beginning of the year, Samsung decided to close its open source robotics project. But Steve was able to basically start a foundation, which is called Open Navigation, to continue the project and ask for several players in the industry to sponsor it. So Dexory sponsored it. And what I like about like ROS and this kind of initiative is that we are collaborating with other mobile robotics companies that could be competitors, but there is more to gain in collaborating than not collaborating and doing everything on our own corner.
Yeah. Oh, that's really nice. And it seems like for robotic students who are kind of studying and learning how to code software for robots, this kind of standardization must be a huge help for them.
Oh, it is. It is. Though the cost of entry is not that cheap in terms of learning. I mean, if you just want to make a robot like drive straight, you will manage to do that much faster without ROS, if you don't know anything about ROS. But if from the moment you want to do higher level things, then once you have ROS on your hardware, you can plug in many pieces of software from everywhere. And this is and for students it's amazing. I mean, you can have like a master student in 6 months having a beautiful proof of concept with a small robot.
Fantastic.
Whereas, like, I don't know, 2 decades ago, that would have been a very big team effort to achieve the same.
Okay. And how did you get involved with ROS?
I started when I was a researcher, like more than 10 years ago. It was the very beginning of ROS at the time. And I had mobile robots to play with. And I was looking for algorithm for inspiration and to try. And this is basically how I started. And then I found some nice algorithms that had some bug. I started to fix them. And this is how I put my feet in the community.
Awesome. What do you enjoy most about your job?
I think it's the fact that it involves so many different moving parts. I think that's the case for all robots, but specifically for mobile robots, you have to understand mechatronics, you have to understand electronics, you have to understand low-level programming, you have to understand high-level programming, you have to understand sensor filtering, mathematical model, and the fact that it's so interdisciplinary makes it hard, but also fascinating.
Yeah, sure. Guillaume, it's been great chatting to you today. I've been speaking to Guillaume Doisy, Lead Systems Architect at Dexory. Thank you.
Thank you. Have a good day.
You too. Thanks for listening. If you enjoy Robot Talk, I'd really appreciate it if you could share the podcast and leave a review to let us know what you think. And if you've got a question you'd like me to ask one of my future guests, you can contact us on social media at Robot Talk Pod or visit robottalk.org. We regularly announce upcoming guests, and I'd love to include your robotics questions, whether they're super basic, a bit silly, or even quite profound, in my next interview. Next week, I'll be chatting to Kate Devlin from King's College London, all about the social and ethical implications of new robotics and AI technology. Until then, I've been Claire Asher, and this has been Robot Talk. Robot Talk is brought to you by the Hamlin Centre, Imperial College London.